Again, welcome everybody. Appreciate you joining us for the December novice meeting. I know it's still November, but in keeping with tradition, our novice meetings are usually the Thursday before our general meetings, and our general meeting is tomorrow evening. So by chance, it happens to fall in November as opposed to in December. But we've got a great speaker tonight. Justin McCollum, who's been a member of the Houston Astronomical for quite some time and a member of other clubs as well, volunteers at the George Observatory, is here with us to talk about Uranus and Neptune. I don't have any other announcements going into this, so I'll just transition right into our intro. Justin graduated from Portland State University with an MS in physics. Since 2005, he's been a physics laboratory coordinator and departmental astronomy instructor. His accomplishments include graduating at the top of his cohort in the postgraduate certification on artificial intelligence and machine learning with UT Austin McComb School of Business in August 2023. Justin has also volunteered at the George Observatory since 2005 and has served in different club officer positions in several Houston area astronomy clubs. So without further ado, it's my great pleasure to hand it over to Justin, who's going to take us on this journey to the outer ice planets.
Well, this is a talk that I did many years ago at Astronomy Day. I think it was 2013. This is pretty elaborate. Hopefully I can get through all this. I suffer from a little bit of laryngomyelitis, so we'll go through this pretty quickly in the presentation. Oops. So one thing we'll cover quickly about the mythology, because there's a bit of a mythology as to the origins of Uranus and Neptune, bit of the mysteries, discoveries, observation, history, science exploration, possibilities, and the future, along with some citizen science and projects and techniques for being able to observe and locate Uranus and Neptune. One thing is that it has a very sort of the mysterious in terms of the Greek origins. Out of the chaos from the primordial times, the earliest records exist of the origins of the Greek pantheon of gods. Uranus was referred to as Father Heaven. Now, knowing the nature of Greek mythology, there are several versions as to the origins of Uranus. One referring to the fact that Uranus was simply just born out of the chaos without any predecessor, or that Uranus was born out of Gaia, known as the Mother Earth, and ended up marrying Gaia and having the children, which would be the Titans, which were the predecessors before that of the Greek gods. Cicero, the ancient Roman politician and orator, referred to Aether and Hemera as the air and day, and from them, one of the offsprings was that of Uranus and of Gaia. There was the son of Nyx from the Orphic hymns, and Nyx was the personification of night. So Uranus was born as one alternative route out of the nightness of the celestial skies. Uranus and Gaia did precede the generation that preceded the Olympian gods. So we had the Titans, there were the Hekaton Kaheris, which were the 300-armed giants. Then we have the Cyclopses, like we find in Odyssey and the Iliad. Uranus, though, despised his children, imprisoned them in what was known as Tartarus. If you ever read the I'm trying to remember what it was. There was the Dante's Divine Comedy about the 6 or 7 circles of hell, and below that was Tartarus as being worse than that of hell. Of course, Gaia was upset with Cronus, and Gaia was upset with Uranus and had her firstborn son Cronus, we know it as Saturn, literally sort of just did that to his father, literally usurped Uranus as sort of being the continuing sort of father figure with a flint-bladed sickle. One of the ideas was that Cronus punished his father Uranus by chopping him up, and his body parts became the islands that scattered throughout the Mediterranean. Part of his body became Uranus, another part of his body became Sicily, another of his body became Cyprus, and so forth. And when he was vanquished, Uranus being presider over the nighttime sky was now lost partially to that of the daytime. And so there was no longer a sky that was in 24 hours of darkness. It's now part nighttime and part daytime. And Uranus being a of a time before humans when he was vanquished. So it became the birth of real time and began the tradition of the older gods being usurped by the newer gods. In terms of that, you have the 12 Olympian gods who descended from Kronos and his wife Rhea. So here we have brothers and sisters creating the next generation of gods, the Titans being sort of inferior, the Olympians being civilized and intelligent. So this is the tradition among the Greeks where the older gods are usurped by the newer gods, sort of like the creations usurping the creator and being more intelligent. We know that the Mycenaean Greeks had the earliest history of the words for the Poseidon, but the Poseidon god under the Mycenaean Greeks we refer to as the Earth Shaker, as known as this Gaia Echos, which the origin is unknown for the name. But you have the pre-Ionian and the pre-Doric Greeks coming in after the fall of Mycenaean civilization as we go from the Bronze Age into the Classical period. And it's likely that the origins of the Poseidon we know now was originally a landlocked god, as those Dorian and Ionian Greeks came in from the Balkans and moved into Greece, and being surrounded by the ocean waters, well, the waters of the Mediterranean, the Adriatic, and the Aegean Sea. Basically, that landlocked horse god took over the sea gods and became Poseidon, and the original sea gods, the original Aegean sea gods being Proteus and Nereus, were reduced to a secondary level, and the horse god became the new sea god as Poseidon. Around that time, the war chariot and the horse was introduced to the Greeks coming from Anatolia, modern day Turkey, around the time of 1600 BC. And here we have the earliest origin of the terms for Uranus and Neptune, in the case of that of Poseidon. So we have the birth and triumph over the Titans. We have the Greek gods taking over. Rhea protected Zeus. Zeus, of course, sliced up his father. He sliced up Kronos, and the gods were spewed out. They were being freed. And in return, the most senior of the male gods, Zeus, Hades, and Poseidon, took over their part of the universe, the sky, the underworld, and the sea. And they founded Mount Olympus. Of course, Poseidon and Apollo had offended Zeus at certain times, so they were temporarily stripped of their divinity, went off to build the city of Troy and its many defensive walls. And the time before Poseidon was reinstated in godhood had many children, both human and divine. So here is sort of the lineage of the Greco-Roman gods. We have to remember that Uranus and Neptune is in the Roman, and in the Greek we have Uranus and Poseidon. And we have here all the way up to the fourth generation of deities of Hermes and Apollo. So we had older gods being replaced by newer gods, being replaced by newer gods, and the newer gods usurping the older gods, not down here with the big family, but in these generations prior. Of course, that was the male gods being usurped, while the female gods were continuing to exist. Rhea still existed, Gaia still existed, but Uranus and Kronos were pretty much obliterated from existence. Okay, there's a common misperception that Sir William Herschel, when we get into the history, was the discoverer of the planet Uranus. And we officially date that to the 13th of March of 1781. But we know that originally John Plumstead, who founded the Royal Greenwich Observatory under King Charles II, had his first observation of Uranus back in 1690. And back then, the observatory was known as the Plumstead House. Well, it was actually cataloged in a store in Taurus, known as 34 Tauri. And when astronomers were actually seeing Uranus, they were actually seeing this as a star that was moving across the sky. When we get to the time of Lemonnier, Pierre-Charles Lemonnier, who was a French astronomer, and the big thing as we went into from the 17th into the 18th century, the big thing was observing comets. And this was sort of around the time where William Herschel was beginning to move his telescope across the sky and see these nebulous objects. He made 12 recorded observations of Uranus from 1750 to 1769, and astronomers of his time actually thought it was a star moving across the sky. But one thing about this star they were noticing is that when they put more power on it, they found it was getting bigger and bigger and bigger in size. The same way you look at Saturn and Jupiter in a telescope, they appear to be bigger and bigger in size. So the technical date for discovery was on the 26th of April of 1781, but as a comet, not as a planet. So even William Herschel thought it was possibly a comet or a nebulous object that moved across the sky. I'm sure everyone have seen, I don't know how many of you have seen Larry Mitchell's presentation on William Herschel, but William Herschel, this was the scope that he used to look for the planet Uranus across the sky and see it as a comet, not really as a planet. So it was the fifth astronomer royal, Dr. Neville Maskelyne, who actually looked at this and actually thought it was a new planet among his reports. He reported back to William Herschel. Of course, Herschel didn't really believe in any of his reports. There was a big debate as whether or not this was actually a planet or a comet. Some thought in William Herschel's camp that this was actually a comet, a green-colored comet, because we see a lot of comets being green-colored. Others were beginning to follow Maskelyne's idea as that of being a planet. So there was sort of a debate as to classifying this totally brand new object and whether or not it was really a comet or that of a planet. Now, I don't have any pictures, but the Russian astronomer, Andrews Johann Lexell, actually did a bit of mathematics using the only math he had at the time, which was Kepler's laws of planetary motion. And given how they actually measured objects north and south of the celestial equator, along the ecliptic, and using something what they call north polar distance from the north celestial pole, before there was declination and right ascension, he actually saw it as moving across the sky in a circular orbit about the sun. The perception then was that it had to be a planet. Now over here we have the Berlin astronomer Johann Albert Bode, and we have his Bode laws for planetary motion, and he referred to this moving star as having a circular orbit around the sun beyond the orbit of Saturn. No other stars were seen to be going in this circular orbit because of the celestial sphere and all the stars being stationary. And the only thing that would actually orbit around the sun would be the planets. William Herschel notified Sir Joseph Bank, who was the first baronet and was the Royal Society president at the time. When William Herschel began to realize that this was actually a planet, he actually notified King George III. And when you compare the inflation of currency, you can actually use an equation, and the annual stipend that King George gave him was around £200, which in today's money would be over $46,000 when you base it on the historical standard of living. So he was given quite a stipend at that time. That's what £200 back then in the 18th century would equate in today's US dollars. So what to name the planet? Well, there were many possibilities. Herschel wanted to name it after King George, George's planet. The French astronomer Lalande wanted to call it the planet Herschel after William Herschel. The Swedish astronomer Eric Prosperin wanted to refer to it as the planet Neptune, but it was Bode who proposed the idea of Uranus following the lineage of the Greco-Roman pantheon of gods. You had Jupiter before Saturn and Saturn before Uranus. So you had Zeus, Kronos, and Poseidon. Jupiter, Saturn, Uranus. Actually, I should say Zeus, Kronos, and Uranus. Jupiter, Saturn, Uranus. And the term, people don't realize this, but the Georgian planet, George's planet or George's star, was still used in the British Royal Almanac until about 1850. So it was only up until the mid-19th century that the planet was not officially called Uranus until about that time when the British decided to finally change His Majesty's nautical, or Her Majesty's nautical almanac, because this was the time of Queen Victoria. And the term Uranus began to be widely used after around 1850. Now, Going from Uranus to Neptune, there's sort of the connection, because the thing about Bode's law is that there's a basic mathematical equation here where you use a simple formula to try to predict the position of planets as they are further and further away from the sun. And it's a pretty accurate formula up until you get to about the time you're getting past Uranus. And noticing with Neptune, they're finding there's a greater deviation. That is, there's a greater separation where Bode's law begins to fail. As here we get the prediction of where we expect planets to be at certain distances based on looking at the planets that were known prior to the invention of the telescope, going from Mercury to Saturn as the classical planets. And we can see this sort of changing in the rules as we see this greater inaccuracy in the Titius Bode law, or the Bode law, when going from Uranus all the way out to Pluto. So we find that there are discrepancies. At the time, the astronomers saw that there were discrepancies between where they were predicting where Uranus would be in the sky in its orbit and the actual observations, particularly the irregularities when they're trying to use Newton's laws of motion. But a lot of the mechanical clockworking gears they had, and this is the funny thing, there was a lot of inconsistencies in the coordinate systems being used. The clocking and gearing mechanisms on the telescopes were not very precise. And when we correct for those errors in the clockwork mechanisms, we realize that you can use Newton's laws as well as Kepler's laws of planetary motion to accurately plot the position of Uranus and Neptune across the sky. And so you don't really have to have any sort of mysterious effects. But at that time, given what it was known, actually people thought that there was some mysterious planet beyond Uranus that was somehow pulling Uranus that was greater than the influence of the sun. Now, Pierre-Simon Laplace would come around in 1783, and his mathematics extended the field of physics dealing with conservation of energy and momentum to provide greater accuracy in finding these planets about the sun. Now, there's this big thing between the British, the German, and the French as to who was the discovery of this of Neptune, because Neptune was the first planet to be predicted mathematically. The first person to predict that there was some unknown body tugging in Uranus' orbit was John Couch Adams. He was a Cornish astronomer in Great Britain, a mathematician and an astronomer. He proposed the possibility of a planet orbiting beyond Uranus around the 3rd of July of 1841. Several years later, a mathematician by the name of Leverrier was working on this independently, and he proposed a common theory. Well, he disputed the common theory based on Bode's law using his own mathematical equations, and he presented this to the Academy of Sciences in Paris in November of 1845. And it was used to predict the failure as to why astronomers are having a hard time trying to find the positions of Uranus across the night sky, going from constellation to constellation. He did have help from a German astronomer working at the Berlin Observatory. Now, both men, Couch and Leverrier, they knew about each other, but they were sort of competitors and rivals and colleagues in using mathematics to study the heavens and to study the mechanics of the orbits of the planets around the sun. Both continue to do their investigations as to the difficulties of investigating Uranus's orbit. At the time, there was no certainty about determining about the mass and the orbit of the proposed body in the case of Couch's work, whereas Leverrier did propose in his memoirs, with information about the possible mass and the orbit of the planet, how to determine the positions of Uranus as it moved across the sky. Adams gave his final solutions to the Royal Greenwich Observatory in September of 1846. Leverrier did it much earlier, just a few days earlier, 31st of August of that same year. And the idea that this was some sort of effect of gravity by this mysterious planet working on Uranus and moving it into a different direction based on the prediction of the orbit using Newton's laws. Now, Leverrier had a good correspondent with Johann Gottfried Galle. who worked at the Berlin Observatory, in fact, Gall in one night on the 23rd of September, with the help of his assistant, fellow German astronomer Henri Louis d'Arrest, and they used a special refractor known as a Fraunhofer refractor, about 10 inches. And within 1 degree of Leverrier's predictions, in one night of observation, using that's the telescope they used. That's the Berlin Observatory. Of course, in the night skies of Berlin around that time period in the 19th century, this was before they had electrical lighting. The skies were just pitch black in Berlin at that time, unlike today. And near the boundaries between the constellations of Capricornus and Aquarius in that year, they found the date of discovery, 24th of September in 1846. That night in Berlin, in one night, within just 1 degree of sky, and this is the area there around Aquarius with Neptune, focusing up there's Saturn nearby. There's the size of the moon. That was the area of 1 degree. They scanned over an area of 1 degree of sky, and they found Neptune to be only about 2 arc seconds across. But in one night of observing, using Leverrier's mathematics, boom, they were able to find the planet Neptune. Now, this was a big upset for the British. One thing, Adams' calculations were off by about 12 to 20 degrees, whereas Leverrier's calculations were off by about 1 degree. So you can see the difference here between trying to scan across the sky of 12 degrees versus 2 degrees, finding a planet that was significantly smaller in terms of the area of the sky it covered with respect to Saturn. But who was really the first to discover Neptune? Well, we know that Galileo actually had records of describing a mysterious blue star that moved against the background, just like Uranus, not being fixed with the calculations. In fact, here we have 3 nights of him actually observing this mysterious blue star, which is right here, right here, right here. So that's actually Neptune with respect to Jupiter and its moons. And we can actually see there's Neptune here, there's Neptune there. But he mistook it for a star, even though it's moving across the skies. Of course, he couldn't enlarge it with his little refractor. But that was a missed opportunity for him to actually have discovered this planet more than, 230 years before this little thing between Leverrier, this little rivalry between Leverrier and Couch. We know that the astronomer Sears Cook Walker, who for a time worked at the U.S. Naval Observatory and the USCS, which is now the National Geodesic Survey, found that Joseph Jerome Lalande, actually on top of looking at Uranus as 34 Tauri, actually had position errors for a blue star moving across the sky in 2 days in May in 1795 at the Paris Observatory. While Sears Cook Walker, using the data from and the mathematics of Leverrier, found out that working backwards, that these are 2 confirmed possible pre-discovery observations of the planet Neptune. And Lalande actually described it as a blue star moving across the sky, shifting from constellation to constellation, just like that of Uranus. Of course, he mistook both of them as being stars, not planets. And here we have those 2 nights in the proximity of Gamma Virginis. I did this with Stellarium. There's Kappa Virginis in Virgo. There's Neptune. And a blue star mistaken with a correction in the celestial position, because here we have here, 2 nights may not seem a lot, but you can see where this is over this star, and there's Neptune being shifted with respect to that star above. Now, Adams versus Leverrier, this was actually a rivalry between Britain and France, as who would receive credit for the discovery. Adams was pretty bitter because he thought it was being ignored by the British scientific community. His calculations placed a high degree of inaccuracy as to Neptune's true position based on what he published in his later publications with his mathematical equations and in the locations. The Cambridge Observatory spent 6 weeks using his equations to look for this so-called planet during the whole summer of 1846. Well, they didn't find zip. But using Leverrier's mathematics, the Germans at the Berlin Observatory, in under half an hour on one night, found the planet Neptune. In one night, because it was only off by 1 degree. I mean, imagine being able to do that with one publisher with equations showing you plotting positions and using an observatory, and in one night, in half an hour, over a degree of sky, finding your ideal planet. Whereas if you take another author with his calculations and his predictions, trying to go across the sky in 6 weeks and being off by 12 to 20 degrees and not finding the planet. So really, it was the French and the Germans who got there first. The real thing is how the British wanted an equal share in the credit for this national prestige, but the embarrassment actually led to a nasty cover-up. The British did not want to know about the fact that Adams was very vacillating in his behavior, or there were questions about the scruples of his mathematical works, because there was some possibility that maybe Adams knew about Leverrier's work and sort of plagiarized his material. Basically, on his most earliest results, everybody went onto a wild goose chase. And that was due to the poor results from his calculations. And nobody wanted to think, well, they were the Greenwich Observatory was wasting time in a wild goose chase searching for a planet from an astronomer and a mathematician whose equations turned out to be highly inaccurate. Some people wanted to charge the astronomer royal, Sir George Bedell Airy, as the person who sort of ignored Adams's work. And Adams, Sir Airy, wanted England to have the pride of discovering a new planet in the tradition of William Herschel, and asked astronomer and fellow clergyman James Challis to go on a systematic search of the sky. And people like to remember poor Challis as the man who missed the opportunity for discovering Neptune for Britain in 1846 because they couldn't find it at all across the sky. They were looking across it and didn't find anything. What we realized was that the British were actually, there was a lot of savage beating of the British press by poor Airy. Poor Airy was receiving a savage beating because they figured, oh, the British should be the best in mathematics. The British should have continued on with the tradition of William Herschel, finding this planet, working out the irregularities in Uranus's orbit, and trying to be the credit of finding this undiscovered body. There were a lot of fake letters, a lot of responses to the information between Airy and Adams, accusations of miscommunications. People accused Adams of being tardy in his mathematics and in giving his information to Airy, but Airy, of course, thought it was not his responsibility. He was sort of passing the buck. A lot of the blame went to Adams, and a lot of blame was being given to Challis here. What we find was that there was actually a huge backlog of astronomical observations for the observatory, because the one thing was comet observations was the primary goal for the British, because that was the primary thing in astronomy at the time. Looking for comets, because that was sort of the cutting edge for astronomy at that time. Well, looking back into the work, it was actually determined that there were observations made of Neptune. They did follow along the mathematics of Leverrier, and it plotted a nice orbit that showed the prediction of Neptune's orbit around the sun. And so actually they had the data for Neptune's orbit. They had the recorded positions for Neptune, but because of the backlog that Challis had to work with in trying to update comet observations for the observatory for research in astronomy, it was totally missed altogether. Oops. So the British did have the data, but because they wasted a lot of time looking at comet observations, they totally dropped the ball on this, because the information was there. They could have filtered out the comet observations, have the observations for Neptune weeded out as that blue body moving across the solar system as the planet orbited around the sun across those constellations of the zodiac, and they would have been able to get the credit months before the Berlin Observatory. So that was sort of a blunder. Sir Aries, of course, intervened on behalf of Adams. I mean, there was a huge disinterest by the British to systematically scan the sky looking for a new planet. But we know that Challis's notebooks revealed that Neptune was actually observed twice in 1 month before Galli and DRS confirmed it on September the 24th, 1846. So this was a lost opportunity, even though the data was there, buried among the comet observations. And he explains his actions to Airy in October that same year. I mean, Airy took up the mantle and gave it to Chehalis as to try to get the credit for looking for that new planet. But Chehalis was just overwhelmed with all those comet observations as astronomers were pushing for those comet observations over looking for the planet Neptune, even though Airy wanted to get Britain to have the credit and tradition of William Herschel to try to discover another planet on top of the legacy of discovering Uranus, even though William Herschel actually referred to Uranus as being a comet and didn't quite believe the idea of it actually being a planet. The documents were actually kept secret for over a century. It was decided for political reasons for Leverrier and Adams to get equal credit for the discovery. There was no long-term bitterness of anything. Adams sort of blamed himself for failing to convince the astronomical community, literally due to the failure of his mathematical equations. But the British community realized after the fact that they had to rally around Adams for the sake of national prestige. And the French actually found Adams to be a very forward-going guy, whereas there was little sympathy for Leverrier because, unlike Adams, Leverrier was a very arrogant, overly assertive person. And Adams was given priority and credit. Well, of course, Adams gave priority and credit to Leverrier and Gall to reassure his academic reputation within the community. And a lot of the math mess up in his equations, and a lot of his work was actually suppressed for about 100 years. So we didn't have access to Adams' original mathematical formulas, as well as the observations made at the observatory, at the Royal Observatory, and the backlog of data that Challis had to work with. Leverrier didn't want Adams to have any equal credit for it. He fought against it. He alienated and angered a lot of people and nearly destroyed him. He was a real ogre, a real despot. He was traumatized by the whole event. Eventually, he was removed as a head. He was removed from his position as head of the Paris Observatory. So he lost his headship in the Paris Observatory. As director of the Paris Observatory, he got it back, but only after his successor had drowned in a river. So it was sort of like there was no one really to replace his successor, so he was sort of brought back into it. There was probably a lot of miscommunications and troubles and interactions between Adams and Leverrier. The idea is that most men were probably suffering from a form of Asperger's syndrome, which tended to make it difficult for individuals with Asperger's syndrome to properly communicate with each other. And so there was this British cartoon of where I found it, no, I'm taking credit for it, no, that's not fair, you're cheating for it. And this was this big cartoon I actually found in an old British and a French newspaper from the 18th century. So it began this really sort of big thing as to who took credit, who did not take credit for it. And it was just, in the end, it was decided, okay, everybody will take credit for it. It will be equal credits on both sides. And just leave it as that. While those documents were actually discovered by a campaign by Dr. Asian, who was graduated from the University of Wisconsin-Madison. He was director of many of the great observatories at the time around the 20th century, won many awards in astronomy. He was considered one of the best observational astronomers of his time around the mid-20th century. He actually ended up discovering the documents. Among them was known as the mysterious Neptune file. The British wanted to keep this secret, and it took a long, long time. He fought for many years to get access to these documents because they wanted to keep them classified, but he managed to move through the vast archives of the Royal Greenwich Observatory, and prior to his death in Chile around 1999, actually found this information. And in a BBC interview in 2003, many of the claims about Adam's inaccuracies and vitillations actually showed up in a BBC documentary. Not with Edgen, he was already dead. But he was the first to claim that Aries actually ignored Adam. He was a high-bound superior, and Adam at the time was a young upstart. And so there was a cover-up so that a young upstart would not embarrass a high-bound superior who, due to his ego, didn't want to sort of look like he dropped the ball in trying to perfect the mathematics, trying to clean up some of the equations, and trying to prioritize looking for this planet over comet observations to try to find this planet. And I remember there was an article in Scientific American by these three authors who were able to finally publish what was known as the Lost Letters in Neptune's Revelations. And this was the case of the Pilfered Planet, and you can find it online from the 22nd of November 2004. And it was in that article, Scientific American, where this was finally let out in the open, and the Royal Observatory had to realize that really the primary credit for Neptune should really go to those other than that of the British. So who would take true accreditation for it? Well, can't really give it to Galileo because he missed it as an opportunity. Leverrier took only half an hour to find it based on his work. Galilei found it using just one night using Leverrier's calculations. D'Arrest helped Galilei considerably in finding Neptune. Scheele saw it, but got lost in all those comet observations. Galileo and Lalande mistook it for a star. John Herschel found it in 1830, later knew it was a planet, but also mistook it for a star. So really the credit goes to these three men right there. That's Leverrier, there's Gall, and there's D'Arrest. So really the credit, doesn't go to the British. It really goes to the British and the French. So the poor British really lose out in the end. Now, naming the planet, it was Francois Arago, who is the 25th Prime Minister of France. And it quickly, even though the first proposal was to name the planet after Leverrier, well, Leverrier was very unpopular, so the consensus very early was to name it after Neptune, in honor of Zeus's brother, the god of the sea. And not much was known about Uranus and Neptune, not much was known about these planets other than they were not very far away, although they were not as far as Pluto and the comets. They were very not very dim, but they were very small in a telescope. You need a lot of magnification, and it was not until the rise of spectroscopy and photometry and combining them together into spectrophotometry that a lot more information would be acquired about the planets. The mathematics and astrometry, which is basically a field of astronomy where you measure out the positions and coordinates of objects in the night sky, that helped determine not only the orbital periods of these planets, but also how long it takes for them to move around. What's their orbital period? What is their years? The distances, orbital velocities, the masses of these bodies, energy, momentum, and so forth. One of the things was the rise of spectroscopy in astronomy, particularly with the suns and the stars. And there was stellar spectroscopy studying the sun. Joseph von Fraunhofer is this man right here, who is actually the first to use the concept of Fraunhofer lines in stellar spectroscopy to look at the composition of objects in terms of light that radiates out of them from outer space. And we call those the Fraunhofer lines. Sir William Huggins, who was the first pioneer in astronomical spectroscopy and was the first to adopt what was known as dry plate photography in imaging deep sky objects. And Pietro Angelo Sacchi was the first to confirm that the sun is a star, because he looked at the spectrum using the Fraunhofer lines of the various stars in the night sky and compared that with the sun and realized that the sun was a star, not a special body. Now, the first to observe the spectra of Uranus through a glass prism in 1869, 1871 was Father Sacchi. He didn't find any Fraunhofer lines and assumed that Uranus was emitting its own light, the same way the sun was emitting its own light. But then we get to Sir Joseph Norman Lockyer, who from 1836, 1920, around 1899, and some ultraviolet radiation does make it to the surface of the Earth. So a little bit with UV spectroscopy, he was able to confirm that light from the sun was actually reflecting off of the Uranus's atmosphere. So that was the first observation of looking at the spectra of Uranus. We get into the American astronomers Rupert Welt and Melvin Spitzer, who actually discovered spectral lines of methane that allowed, when looking at the methane in Uranus, they realized that Uranus and Neptune actually had a deeper penetration. You can look deeper into the atmospheres of Uranus and Neptune by looking at the amount of methane in the atmosphere. And as spectroscopy and photospectroscopy began to develop even further, Uranus was slowly beginning to reveal some of its mysteries, but there were many unknown features that remained a mystery with, with Uranus and Neptune. By the late 1980s, there was only three things that were certain about Uranus. One is that it was not generating more energy than it was receiving from the sun. Nitrogen and methane was its primary chemical gases, and the deepest had the deepest atmospheric transparency of all the gas giants, and no other discrete features were observable until the time we had Voyager 2 and the Hubble Space Telescope. And then we're getting a bit more into looking at the atmospheres of Uranus and Neptune. Now, we're a bit short here on time, but we did have a history of the moons of Uranus and Neptune slowly being discovered. There was, according to some writings of William and Herschel, of discovering titanium and Oberon 6 years after he discovered Uranus, but he claimed in 1790 to have discovered 6 moons and possibly a ring. But there were no later confirmation of these observations until the time of William Lassell, who discovered Ariel and Umbriel in 1851. William Herschel gave them their names in 1852, and Miranda, which was the 5th major moon, was discovered by Gerhard Kuiper in 1948, and then there would be no other moons discovered until the time of Voyager 2. Neptune, sort of the situation before Pluto. By the time Pluto was discovered, and until 1930, it was considered the furthest planet from the sun, so it's known as the penultimate planet. They knew that in 20 of its 165-year orbit, that it would be closer, that Pluto would actually be closer to the sun than Neptune. And today it's known as the 8th and the last of the classical planets. The moon Triton was actually discovered by William Lassell in just 17 days after Neptune's discovery, on the 10th of October in 1846. Other than the discovery of Triton, for the longest time, Neptune appeared not to have any other moons. It resembled the twin planet of Uranus. They did measure the amount of radiation coming from the planet, determined that Neptune was generating its own heat. It was known that Neptune's distance was about 30 AU, and its axial tilt was estimated to be about 28 degrees. And the time they thought it was receiving 1,000 times less energy from the sun than the Earth in terms of energy planet Earth was receiving from the sun. So here are the various images and graphs. This was from the Encyclopedia Britannica in 1972. This was from the Mount Wilson 60-inch refractor from 17th of April of 1953 at 1,000 power. So you can see the cloud bands right here. This was from 2011. Of course, this was post Voyager 2. And as spectroscopy began to develop, they were assuming that in the case of Neptune, the planet was radiating 4 times as much energy, infrared radiation, as it receiving from the sun. Uranus looked like it evolved differently from Jupiter and Saturn. It showed seasonal variations, and for the longest time, Neptune was used as an albedo standard for planets in terms of brightness. Possibly some gaseous ammonia, hydrogen, and methane were discovered in Neptune's atmosphere, but that was all after 1950. And occultations with the stars confirmed that both planets had hydrogen that make up most of their planetary atmospheres. We did find Triton was discovered by William Lassell in 1846, and Gerhard Kepler, using the 82-inch Otto Struve telescope at the McDonald Observatory, found Nerea, the second moon of Neptune. A third moon was discovered by a team of astronomers on the 24th of May of 1981, and it later became Larissa. And that was the third moon, and then no others were discovered until Voyager 2's flyby in August of 1989. Here are some of the various investigations. Doppler shifting was used to determine the oblateness of the planet, measuring a rotation rate of 18.4 hours. Bright splotches determined that there were possibly cloud patterns in Neptune's atmosphere. So there was possibility in the changes in the cloud patterns. So we have putative evidence of the cloud patterns of Neptune going back to around the mid-1970s into the early 1980s, mid-1980s. A bit of a milestone became that of Voyager and the Hubble Space Telescope, where we really began to see a lot of data coming in, and that was the great milestones in astronomy. So we have an interesting rich trove of photographs and information, too complicated and too elaborate for this presentation, but you can see a lot of the images and data that's been discovered. Of course, what's cool about Hubble is that we actually see a transit of Ariel passing in front of Uranus in 2006. We also have a lot of treasure trove of information from Voyager 2 and the Hubble Space Telescope in terms of seeing the cloud patterns, seeing the moons even in the post-Voyager 2 period, with weather patterns and the moons using the Hubble Space Telescope. We have also extensive information. Not much was known about the moons of Uranus and Neptune prior, other than they were believed to have been icy balls with no atmosphere or any distinguishing surface features. It's been known for a long time that Triton is possibly a captured KBO object, a Kuiper Belt object, a comet body similar to that of Pluto. It follows in a retrograde orbit, meaning it orbits in the opposite direction because it didn't form with Neptune. Very high orbital inclination with respect to Neptune's orbital plane, and it's actually locked above one of Neptune's hemispheres. So it'd be as if the moon was locked over the eastern hemisphere of the Earth, or let's say it's over the Americas, and in the eastern hemisphere among the Europeans, they didn't discover the Earth's moon until they actually would have sailed across into the western hemisphere to the Americas. So nope, there's the moon right ahead. So imagine if the moon was just orbiting over the Earth, just trapped above the western hemisphere as being gravitationally locked. Well, that would have been an interesting thing in the history of astronomy here on Earth. Imagine what it would be as if the moon was just hovering above North America and the Europeans didn't discover it until Christopher Columbus sailed west in 1492. That's the situation with Triton in its orbit around Neptune. There's a lot of information. We know more about the composition, about the size, about the brightness, possible subsurface oceans, heavily cratered surface. There's a brightness, chemistry, a lot about there's ultraviolet radiation that actually breaks up the basic chemicals like methane and ethane and produce a lot of the complex organic chemicals that really give the moon sort of their dark reddish color. And we know a bit more about the mass proportions of the moons and the reed structures of Uranus. Same thing about Triton. We have the luck that Voyager 2 actually flew by Triton, learned a lot about its chemistry, the water ice, the carbon dioxide ice, the nitrogen ice. We know that it has about 1/70,000th the surface pressure of Earth's atmosphere. There actually are clouds of methane over that of the moon, a high brightness, a lot of cryovolcanoes. These are very cold volcanoes that actually spew a lot of cold gases into the environment of Triton. A lot of complex geology, ridges and valleys, not a lot of craters. So there's a lot of resurfacing that has taken place on Triton. It's a captured body in close relation to Pluto. There's actually a theory that Pluto and Triton were a binary planet. A star billions of years ago pushed them out of their orbit. They sort of went into this big elliptical orbit around highly elliptical orbit around the sun, and then as they pass by Neptune, Triton was grabbed by Neptune, and Neptune pushed Pluto into a new orbit, and Neptune captured Charon and formed into a new binary system. And we now know that there are many minor moons that actually orbit Neptune. The rings of Uranus and Neptune, I'll say about this, there are plenty of rings. They're very tight. Many of them are very separate arcs. They're very, very dark. The composition is uncertain, but possibly there's a case where you have something as basic as water, ammonia, and methane, and carbon dioxide. They react with ultraviolet radiation, and a lot of those like dark carbon-rich materials actually appear as a dark sort of reddish color. But as for the bluish color, some of the rings, that's a bit of a mystery. So there's a lot about the rings of Uranus, a lot of theoretical ideas about the minor moons being shepherd moons and pushing the ring material out, and sort of strange sort of gravitational effects, creating these thin rings. But future missions to Uranus and perhaps new discoveries with the James Webb Space Telescope may provide a bit more information. But there are publications prior in the decades before Voyager 2 where astronomers were seeing occultations of the stars near Uranus before passing in front of Uranus, like the stars would be changing brightness before being occulted by Uranus itself. So there's sort of these sort of unconfirmed possible detections of the rings of Uranus, which was very difficult, if next to impossible, given the technology of telescopes and photometry and spectroscopy prior to Voyager 2, going through the mid-1980s. But that changed with the Kuiper Airborne Observatory. When you fly up in the stratosphere, you get access to a lot more infrared astronomy. So they did have a 36-inch cast screen refractor, and through occulting with the star here from the Smithsonian catalog, they actually were able to confirm the existence of the rings around Uranus. They actually thought it was one big, thick ring rather than just a grouping of rings. And you can credit it with these group of astronomers using this prior to the Kuiper Airborne, this was the original observatory, Airborne Infrared Observatory. They had a later observatory that they retired several years ago. NASA no longer does those airborne infrared astronomy up in the stratosphere. But this was the C-141A jet transport aircraft that was used up until the mid-1990s. So we're pretty much certain about the composition of the atmosphere. We know a lot about the surface gravity, the axial tilt. And here I put this in terms of orbital period, surface area, volume, and mass. Just know that 1 AU is the average distance between the Earth and the Sun. That way you have a comparison as to the size and the mass of these planets in comparison to the Earth. We know a lot about the atmospheres of these two planets, but there has to be there's a lot of future missions to Uranus that can provide us with a bit more information because there's a lot of unanswered questions. One thing we know about the two planets is that they don't have an interior of solid or liquid hydrogen, based on studying the behavior of these planets and how the moons orbit around those planets, but more of a mantle of water and ammonia ice. We do know that the auroras actually occur around the equatorial regions because the magnetic fields are off axes. So that means it's seeing the auroras around the equators rather than at the polar regions. Uranus, we can be guaranteed it has the coldest of all the planetary atmospheres. It's actually colder Uranus than with Pluto. And that the fastest planetary winds are with Neptune, because Neptune actually generates more heat than it receives from the sun, more so than with that of Jupiter. And those are examples of Uranus. We know about the orbital resonances of these cold, icy bodies, these Kuiper belt objects with respect to Neptune. And we call those Plutinos, Kuwanos, Tutinos, because every time, let's say in the case of the Tutinos, every time Neptune makes two orbits around the sun, these Tutinos orbit once around the sun. Now, these are sort of the proposal for missions. Original idea was to actually take the Cassini spacecraft with what fuel it had left, cut its mission early with Saturn, and escape out to a 20-year journey towards Uranus. That didn't work out. Another is a decadal proposal for a Uranus orbiter and probe on a 13-year journey to the planet, using a model very similar to the Pioneer 11 Venus mission. It was a mission by NASA back during the time of the late 1970s, where they actually sent a lot of small probes into Venus's atmosphere. The Russians did that very successfully. That was the only time the US actually did it. Some of the probes actually lasted for several hours on the surface. Well, one of them lasted for several hours on the surface of Venus. The UK scientists actually proposed a joint NASA ESA Uranus Pathfinder spacecraft mission, a very cheap version. Neptune, the only proposal was this mission right here, where they would actually send an atmospheric probe to penetrate Neptune's atmosphere, a sort of a nuclear-powered mission using fission-based electric power and propulsion to orbit around Neptune and actually have a lander to land on Triton and investigate the surface. That would have been a mission whose cost would have equaled that of the James Webb Space Telescope. But any mission to the outer gas giants or the icy giants would take anywhere from 10 to 20 years to achieve. Okay, so I'm going to finish this up. One thing about Triton is that it's not all that difficult to observe it under stable weather conditions, decent dark skies. It's usually brighter than 12th magnitude, and 400 times the power in 10 to 18-inch refractor telescopes will do. So under the right conditions, you can pick out Triton from Neptune. And you can actually do this with stellarium and plot the orbit of Triton as it goes around Neptune. And with Neptune, you can actually see some cloud bands. This is a photography, so you can see variations in the color. I know that looking through telescopes out of the George Observatory, you can actually see two cloud bands, different shades of blue. In the case of Uranus, I've actually seen these color bands in visual observing with the 11-inch refractor out of the George, but the moons of Uranus are a lot fainter, even though Uranus orbits 1 billion miles closer to the sun. So you have to be on very, very dark skies. You have to usually use a large telescope to see the color, to get out the cloud features and the moons, 16 to 18 inches. But usually a good refractor, an 8 to a 10-inch refractor or a 6-inch refractor with photography, you can really pick out the colored bands here. There's 3 cloud colored bands that I've seen at different shades of turquoise and sea green. Oberon, Ariel, well, Oberon and Titania are very easy to see. Umbriel and Ariel a bit tougher. But that faint dot there is Miranda, and you really need to pick it out in an 18-inch telescope and really put a lot of power, like 500 or 600 power, to really pick out Miranda. Because sometimes Miranda is really hard to see because with averted vision, it really pops out around 18th magnitude. Now, how to observe them? Well, this is going across the sky around Aries, and this is through June of 2020. This is through December through up to January of 2024. So from 2019 to 2032, you can see Uranus moving across the sky. Right now, currently, it's around that of moving out of Aries into Taurus. So there's the part of the sky where it's located, and it's currently undergoing this retrograde loop, which extends from May of this year through January of 2024, and probably going all the way through April. But it is a naked eye object, but you can actually observe it in a 4-inch telescope to give it some size. And the angular diameter is just a few arc seconds. So it is a naked eye object if you know where to look at it in very dark skies. But if you want to get any size out of it, it'd be a good 4-inch telescope will do it. Neptune is trickier. It's a binocular object. There's no way you can see it with a naked eye, but an 8-inch telescope will give it some size, but it is about usually half the size in arc seconds compared to that of Uranus. But it's also undergoing current retrograde loop, and it's in this circle right here between Aquarius and Pisces. So both planets are currently in their retrograde loops. This is from the Hubble Space Telescope, so with different wavelengths of infrared light and visible and ultraviolet light with a Hubble Space Telescope. You can penetrate the depths and see the different cloud layers with different wavelengths of infrared radiation. This is actually from the James Webb Space Telescope with the near-infrared camera instrument. So you can see the moons, shepherd moons, the rings, and the cloud bands of Neptune. You can see how Neptune is exceptionally bright in the infrared. And one thing about Neptune, it's very consistent in the dark storms and vortices. Here we have the Great Dark Spot from Voyager 2 flyby in 1989. But we can see over the years how the storms have come and gone. And as of 2020, with the Hubble Space Telescope, this is with the Wide-Field Planetary Camera 3, the last of the instruments added on with Hubble, and that's the Great Dark Northern Spot, and there's another dark spot right there. I don't know if you can see them with telescopes, with the 24, 30-inch telescopes. That would be a big challenge to see looking at those dark spots. But you can definitely pick out at least one or two cloud bands with that of Neptune. Hubble Space Telescope and the Space Telescope spectrograph that was added on to the Hubble Space Telescope, there are the auroras right there along the equator, because the poles are out here, because the planet is tilted more than 97 degrees. And over here, this is with the NIRCam instrument, with the James Webb Space Telescope. So there are the 5 moons. There's Puck right there that was discovered looking through the images of Voyager 2 after its flyby in the months afterwards. There are some of these faraway infrared galaxies right there. And there you can see the polar cap, the clouds, and the zeta ring, the faint zeta ring. So you can see the detail of the rings more accurately with the James Webb Space Telescope in more detail than with the Hubble Space Telescope, because there's more detail in the infrared when studying the rings of Uranus. Citizen science projects, all eyes on the giant planets. This was actually a project with the New Horizons spacecraft looking for the details to augment the mission of the New Horizon telescope when sharpening its instruments, looking at Uranus and Neptune prior to Pluto's flyby. The website is still there. The links to the New Horizon mission related to Uranus and Neptune is a bit defunct. But ALPO, the Association of Lunar and Planetary Observers, does have a remote planet section. There's nothing on there, so you want to be the first to contribute to the science of Uranus and Neptune with ALPO in their remote planet section, which is under work right now. Go right ahead. I mean, even citizen scientists can contribute to the discoveries and observations. I know going back here, a lot of citizen scientists have actually helped with the New Horizons missions with a lot of observations, both photographic and visual, studying the cloud patterns, the orbital structure, the motions of the moons of Uranus and Neptune, and actually be able to see when the positions are right with photography, with astroimaging of Uranus and Neptune, with the moons transiting in front of Uranus and Neptune, and be able to get some new information, new details, and studying the weather patterns and the atmospheres of Uranus and Neptune, and being able to learn more about the mechanics of the moons of Uranus and Neptune, particularly with Triton, Ariel, Umbriel, Oberon, Titania, and Miranda. All right, and that's the scope of the presentation. I always find that Uranus and Neptune are actually quite fascinating planets that require more discovery. And there's always new information to be added in. This actually came from the Keck Observatory, where they were studying it in microwave radiation. And the planet is simply just powered by microwave radiation for its atmosphere, and it's showing a lot more complicated cloud bands rather than the bland color you get with visible light. And that's the scale of my presentation.
Thank you so much, Justin. It's always wonderful to have you present to the club. I'm always amazed by your encyclopedic knowledge of whatever it is you present on. So
this took many years. This took many years of research.
I believe it. Yeah. All right. Well, I was going to see if anybody had any questions that they wanted to ask of Justin. If you do, go ahead and come off of mute and ask away.
Does nobody have any questions?
I don't hear anybody. Justin, do you mind if I take control of the screen briefly?
Go ahead.
Okay. I just wanted to kind of show in a little bit more detail what you were just displaying. So if you're looking at the night sky currently, looking south-southeast, obviously the night sky is dominated by Jupiter and the moon, Jupiter being the second brightest thing in the night sky right now. But you could see here, we've got this nice line of the outer planets here from Saturn to Neptune, very close to the circlet of Pisces, as you'd mentioned. And then just on the other side of that V of Pisces, you've got Jupiter, which is almost impossible to miss. But right there between Jupiter and the Pleiades, M45, is Uranus. So these things are well positioned in the night sky if you've got the right equipment to observe them.
And one night you can do a good observation of all four of these. And if you find these two bright stars here, just to shift from the Pleiades, Uranus will actually appear as a nice, bright, sort of turquoise ball.
Which bright stars were you talking about? These two here?
These two here and these three here. They form this sort of nice, bright triangle.
Right. Perfect. Okay.
And if at the very least you can find Titania and Oberon, because they are the big giant moons.
Right.
Those are the smaller other moons of Uranus that actually orbit outside. So there's Oberon and Titania. You can definitely pick these out.
Let me stop the motion here, but yeah, there you go.
Ariel, Numbriel.
Oops, let me
requires a bit of higher power. Miranda is just very difficult because of just being able to pick it out. I know that I've seen all five moons in the few times I've looked carefully at Uranus. The only other moons to actually observe that would probably be Puck. And Puck is about 20.3 magnitude. And now I don't know if that would be a challenge to see in a 30-inch telescope, but probably with photography, you could probably pick out Puck as in some of the bigger telescopes using that in photography.
Yep. And we do actually have a question by Chris Shoemate. If Chris, do you want to come off of mute and ask your question? If not, I'll be happy to ask for you.
Sure, I'll be glad to. Let me stumble through this a little bit. So this is a factor. Do you think I'd have any luck with visual observation for either Uranus or Neptune, maybe with really, really, really good ideal conditions out at the dark side, or do you think it's a bridge too far?
I've not been out of the dark side for a while, so depending on what its Bortle number. Usually, if you know where to look at, if you actually get yourself familiar with the star field and have enough naked eye bright stars around the area of the sky where Uranus is located, I know that Uranus would pop out as sort of a faint green spot of light, like a faint green colored star. And this is one of the reasons why many of the early astronomers plotted it as a green star. It's odd looking at a green star when given the color temperature spectrum for stars that you either go into the orange or into the blue, and the green light is lost in the white. But Uranus is a naked eye object if you know where to look. It's not as obvious as Saturn, but if you pop it out, yes. And if you can do it in the dark sky, yes. But it will appear as a green spot of light. Neptune is definitely doable in a pair of binoculars, but it will appear as a faint little bluish dot. And you have to look at it from night to night to see how it moves across the sky.
Yeah. And Chris, I would say you would definitely be able to see it with the telescope. Just how much you would be able to see, that's a different question, right? I don't know what the focal length of your telescope is to know what the magnification.
I think 780. I think that's 780. I believe is the focal length. But
okay, so 780. So you're looking at about 110 times 2.5. So about 280x, which should be plenty of magnification, but. The question is,
what's your aperture for your scope?
So it looks like it's 100 millimeters.
Yes.
4-inch. Yeah, with Uranus.
Yeah, that should be.
I've read a few successful observations of spotting Uranus and being able to pick out at least Titania with inverted vision because it is the biggest of the moons. Although Titania is slightly smaller. Triton is slightly smaller than the Earth's moon, and it's better observable orbiting Neptune, even though it's 1 billion miles further away, because it's a lot bigger than that of Titania.
Good deal. Thank you, Justin and Joe. It gives me something to
Yeah.
shoot for down the road. Thank you.
Absolutely. Absolutely. All right. And then Scott, I see Bram answered your question. Yes, I am using Starry Night Pro on the Mac here. So Justin mentioned Stellarium, which is free to download. It's a great program. It just uses a lot of resources on my particular Mac. So I use Starry Night Pro because it's a smoother program for me to use here. Although I don't know why it's jumping around in the screen here whenever I
Myriad is impossible to really observe if you're doing visual observing. Your best luck is to just pick out Triton, which you can see there is that little dot on the side.
Right. Okay. If I zoom in or center, I should say, before zooming in, that helps a lot.
Oh, you have to remember that Triton also has a higher albedo than Titania. And Triton is like nearly 2,000 miles in diameter, whereas that's Triton, whereas Titania is about 950 miles across. So it's more than double the diameter. And being over 1 billion miles further away than Uranus has a sort of a big effect in terms of what you can get in terms of power,
right,
in terms of aperture size. I will say this, there's a give and take. If you want to see the cloud bands of Uranus and Neptune, it's best to do it in a refractor, although you cut down the brightness coming from Triton and from the moons of Uranus because it gets dimmer with that higher focal ratio. So there's a give and take.
Okay, thanks for that. Any other questions for Justin? All right. Well, Justin, thank you again for this wonderful presentation. Like I said, this was chock full of a lot of great information. Hopefully we'll have some clear skies here to take advantage of this planetary alignment. And I see Walt chuckling a little bit. But,
if anybody wants to have access to my PowerPoint presentation, I'd be happy to provide my email, then share it on my Google Drive so that people can access it as a link.
Okay. Justin, would you mind putting that email address in the chat here so that those who want to get a hold of you can do so?
I will do that. Let's see if everyone sees that.
Yep, I do see it.
And then I'll be happy to provide it if you want to study it in detail. I thought the whole history was very fascinating. I remember when I was in Portland with the Rose City Astronomers Club that they actually had a table of astronomers members of the club who actually brought out old documentation, copies of the Neptune's files from the Greenwich Observatory around the time prior to the publication of Scientific American about the stolen Neptune files. And that was from the original BBC program they had in 2003, and the original workings and discoveries from that astronomer back in prior to his death in 1999, it just literally shocked me. And that was a long process of trying to access the information. And the Neptune files were originally in the 19th century documentation, so they could be a challenge to read given the nature of the grammar used at that time. And the old coordinate systems they used prior to fully adopting the RA index system.
Good to know. Thank you, Justin. Okay. Well, again, Justin, I appreciate the presentation. This was absolutely wonderful. For those who are interested in receiving the presentation, Justin's email address is in the chat there here in Zoom. So feel free to reach out to Justin. And if for whatever reason you don't get it, send us an email, info@astronomyhouston.org, and we'll get you in touch with Justin. So thank you again, Justin. This was wonderful. And thank you all for joining us tonight. If you have time to join tomorrow, I don't think we'll have any good conditions for observing, so you might as well join us. We'll have our general meeting for December, and we'll have a panel discussion to discuss outreach, one of the most fulfilling things that you can do in astronomy. It's absolutely wonderful. So please make a point to join us if you can. If you haven't registered yet, you can go to the Houston Astronomical Society website, astronomyhouston.org, and you'll find the link to register for the Zoom there. So thank you again, Justin. Thank you all for joining us tonight. You all stay safe, and we'll see you tomorrow. Take care, everyone.